Good afternoon and welcome back to the Cutting Edge stage here at day one of CogX 2020. My name is Anushka Sharma and I have been your host to take you through the proceedings today. This is the Cutting Edge stage. This is where we're learning about tech that's being deployed for research purposes and really looking at how technology over the next 12 to 18 months is really going to help you with your strategy for what you're laying into your businesses over the next 5 to 10 years. I'm really delighted to introduce our next session, which is on the power of collaboration, research and community. And I'm delighted to introduce our host for a fireside chat, Irina Kaufman, who is the director and business lead at Facebook Artificial Intelligence. Irina, welcome to you in California. Thank you for joining us.
Hi, everyone. I'm really grateful to be here and presenting and be part of CogX this year. My screen's up. Perfect. My name's Irina Kaufman, and I lead the Operations, Marketing, and Program Management Group for Facebook AI. Across the organization, there is a tremendous amount of innovation happening, both from fundamental research as well as applied research. Today, we'll be sharing how collaboration plays a key role in much of this work. I'll start with a high-level view of what is working in AI at Facebook really mean for us that are here, followed by the role that cross-functional teams play, as well as several examples of how broader collaborations amplify the work's potential. Navisa, a teammate of mine, will then share a deep dive into the FAST MRI project. At Facebook AI, we're working on connecting people to what they care about, powering new, meaningful experiences, and advancing the state-of-the-art through open research and accessible tooling. AI is core to Facebook now. Today, it could not exist without AI. We use it across our family of apps. For Facebook, AI isn't an experiment. It's an extremely important technology underpinning all that we do. We've deployed AI at a global scale. As you may have realized, I'm not a typical researcher or engineer, but have been fortunate enough to be part of some massive projects in the AI space. One of the things I value most about the AI group at Facebook is the commitment to partnership across functions and different roles on the team. We realize that the best work is enabled through collaboration amongst all different skill sets. While engineering is core to the work we do, there are a bunch of teams we work with, including design, product management, user research, and analytics. The collaboration extends beyond our internal teams and is the crux of the research culture. While we strive to be advancing the state-of-the-art in artificial intelligence, we often do so through open collaborations with the community and academia. One example of a cross-industry collaboration is the Deepfake Detection Challenge, which we launched with partners late last year. This was an effort where the community, including multiple industry partners, academics, media partners, and civil society organizations, came together to help detect manipulated media, in particular, deepfake videos. Together, we released the largest data set of its kind. This took tremendous effort and rigor to do responsibly and enable the world to have access to the data set to also help make progress in the space together. Over 2,200 teams participated and 35,000 models were submitted. We realized that many challenges we see today are global challenges that we're stronger to tackle as a community. The challenges of harmful content, for example, affect the entire tech industry and society at large. Facebook AI believes the best solutions will come from open collaboration by experts across the community. How many of you have seen a meme or even sent one to a friend? When we see these, they often elicit a reaction. It seems pretty straightforward what the message is, so how can they be any use to helping us learn about harmful content? Well, you have harmless images and harmless text, but when you combine them, the meaning can become mean. Swapping in different images and the meaning becomes harmless again. However, when you change the mix of text and images, you can create benign confounders to test classification systems and help them learn. When viewing a meme, we don't think about the words and photo independently of each other. We understand the combined meaning together. This is extremely challenging for machines, however. because it means they can't analyze the text and image separately. They just combine these two modalities and understand how the meaning changes when they are presented together. In order for AI to become a more effective tool for detecting hate speech, it must be able to understand content the way that people do, holistically. To catalyze research in this area, Facebook AI has created a dataset to help build systems that better understand multimodal hate speech. We released the Hateful Memes dataset to the broader research community and launching an associated competition hosted by Driven Data. The dataset contains over 10,000 new multimodal examples and images licensed from Getty Images. So that researchers can use the dataset to support their work, we also released the code for the baseline trained models. Engaging with the broader community and researchers to tackle tough challenges is in our DNA. And this effort is one example of partnering for research on hateful multimodal content. In addition to sharing datasets and work through joint challenges, we also share our open source frameworks, tools, libraries, and models for everything from research exploration to large-scale production deployment. PyTorch, for example, is an open source machine learning framework that is used by both researchers and developers to build, train, and deploy ML systems that solve many different complex challenges. Last year, the PyTorch team hosted a hackathon for the PyTorch community to build innovative, impactful models, applications, and other projects that create positive impact for businesses or people. Over 1,400 participants took part, representing over 90 countries around the world and 70 projects. On June 22nd of this year's hackathon will kick off on devpost.com. With an additional category added this year on building tools for responsible AI development. PyTorch is truly a community-driven project, and we aim to provide an opportunity for the community to get together, educate, challenge each other, and build something innovative and impactful. With that, I wanted to thank you for allowing me to share some examples today and give you a glimpse. Given the power to accelerate research we have when working together, I hope these collaborations continue to allow us to drive innovation and bring about cutting-edge research advancements. Next, Nafisa will share a case study on our FAST MRI project, where partnership has led to impact.
Thank you, Irina. So before FAST MRI, let's talk about the MRI itself. Many of you probably have been in these big, loud machines, which generate beautiful images of our internal organs. But there's a problem with it, right? You spend a lot of time, if you've been there, you know, at least 20 minutes, sometimes up to an hour. People are asked to hold their breath. So it creates a problem, and solving this would impact a big group of people, including people who are too sick to stay still. Let's say you are feeling dizzy and you can't stay there for an hour, or children who don't have the concept of staying still. Also, MRI does not cause any radioactive, does not use radiation, so it might be preferable compared to other imaging modalities that are faster. And most importantly, it would increase access to MRI across the world. So for those of you who don't know how MRI works, after you go into scanner and go get the final beautiful looking image that doctors interpret, there's something goes in between. That's what we call case space, because MRIs are gathering data in a frequency domain, and it's usually not interpreted by a human, but that's where the raw data is. And if you look at it, when you fully sample the traditional way, you're sampling line by line and generating beautiful looking image that you see in the upper part of my slide. But if you want to undersample, meaning make it faster, that's the one way to do it. So you're inherently, let's say, only gathering 25% of the original raw case-based data, but then the images don't have enough data to look original. So they have these artifacts, as you see in the bottom part of my slide. So this is where we're thinking about coming in with fast MRI. The idea is, can you undersample the data, raw data, and still generate images that look accurate and as good as the previous ones? And why is it an interesting AI problem? if you might have seen like out there, like celebrity images, their faces being generated by machine learning algorithms and looking, pretty accurate. So we started thinking about, can we put these technologies into good use? And but there's a challenge when it comes to medical imaging. Getting little details is very important. So in this image, you see part of the knee MRI where the damage in the meniscus is only like few pixels large. And traditional metrics that use the natural imaging do not quite work well to detect what has gone missing in the reconstructed image, what hasn't. So evaluation becomes a very interesting problem for medical imaging, and pushing the AI algorithms to do more. So our challenge is threefold. One is in medicine, there is a lot of data generated, but not so much shared. So there aren't really data sets that can you use as a benchmark. And one of the things for FastMRI we needed was to create a data set that could be used by all the researchers solving the same problem. And number two was come up with evaluation metrics. And of course, algorithms who can do can be used to do reconstruction. So this is the most important part of the FastMRI project, I would say, is to finding the right partnership, because you can solve, as a machine learning researcher, you can solve problems using existing, public data sets or something. But if you don't work with experts in the field that can use complementary expertise and build solutions together, it's less likely to be adopted. So this was at the core of our partnership with NYU Langone Health Institution in New York City, which is known for their being, medical research institution. It was dedicated MRI imaging department, team of physicists, doctors, engineers, machine learning scientists working together. And we have teamed up with them to work on this problem together. So we, get help with them in their every step of the, the decision making, the clinical expertise and other expertises they can offer, make sure we're solving the right problem with them for the real world. The other part of the partnership that's important is that they're providing real world data set, one of the largest, and they put it out there. So you can go to fastmri.org and download it and use it for your research as well. And everything done with IRB approvals and their ethical research practices. But then very important part was the having the same spirit like the Facebook AI research team has, that having a philosophy of open scientific research, meaning everything we do together is open sourced and put up publicly, published, so anybody could use and develop further. With that, I wanted to say that we do not intend to so much of replace doctors. A lot of people think of when AI is using in medical imaging, or we do not come up with solutions and ask medical community just to use it. The philosophy behind this collaboration and partnership, why is it quite powerful, is because the idea is to empower the community in both medical and AI research community to work together by providing them a gold standard benchmark data set that anybody can use and have metrics that can be compared with each other with what's the best image reconstruction metric, and then open source models that people can use and compare and build upon. So with that in mind, last year in December, we hosted a public FastMRI image reconstruction challenge. You can go to fastmri.org to learn more about it. And we still have an open leaderboard, meaning you can download the data, develop your own reconstruction methods for making MRIs faster, and upload your results to the public leaderboard and see how you do compared to other researchers. Maybe there are lessons learned that can be done together. So the results of this challenge was very interesting, because we saw many people using different methods than us to solve the same problem, which was that, the purpose of encouraging more of the community to come together, because there are very interesting problems in medical imaging and AI that are often not challenged if you're only working on the natural image space. So medical imaging creates like very interesting problems to push the AI forward. With that, I think if you want to learn more about the Facebook AI, you can check our Facebook page, and also we're on Twitter at Facebook AI. You can always ask questions by emailing. We also have a contact at thefastmri.org if you want specifically ask about the project. But with that, I want to conclude my presentation, and thank you. And I hope you enjoyed the rest of the conference.
Thank you so much to Irina and to Nafisa from Facebook AI there. This is the cutting edge stage. This is day one of CogX 2020. We've just had a wonderful fireside chat from the team at Facebook AI, who are based between California and New York, a truly global experience today as people from around the world join us for the first virtual edition of CogX. We're going to be back on the cutting edge stage from 5 p.m. We'll be having a session on empathetic AI, and I look forward to welcoming you back then. In the meantime, make sure that you're tweeting and sharing your nuggets of information and what you're learning with hashtag CogX 2020. Make sure you get on the platform and network with your fellow virtual attendees. And we very much look forward to seeing you back here on the cutting edge stage at 5 p.m. This is Anushka signing out for now. See you soon.
Want access to more CogX videos? Subscribe now for free at cogx.co.